Guys, myself Mahesh B. Koot, and today we are going to discuss the new chapter called Haloalkanes and Haloarenes. So carefully look at the name, guys. Name itself indicates split the word haloalkanes. So halo means halogen. Yes, alkanes, you know already alkanes are hydrocarbons having single bond. Is it? So haloalkanes are nothing but the derivative of alkanes in which hydrogen of the alkane is replaced by halogen atom. Look at it. Derivative of alkanes in which hydrogen is replaced by halogen. Look at here. So you know already what is general formula of alkanes, guys. CnH2n plus 2. So write any alkane. This is your alkane CH4. Replace one H. So CH3, add one chlorine. Chlorine is nothing but halogen. Chlorine, bromine, whatever you can add. So this is your C2H6 is your second two carbon atoms. Eth. So all are single bond. So ethane. In ethane, just remove one hydrogen and add bromine or chlorine. So these are called haloalkanes. Nothing but in alkane, one or two H or three H are replaced by halogen atoms. So those are called haloalkanes. I hope you understood, guys. Now we have to study. And what about haloarenes? Haloarenes means benzene ring. So in benzene ring, one or two H are replaced by some halogen atom. Look at here. These are the haloarenes. This is your benzene ring. So here it contains here H. So 6H, C6H6. That is a benzene formula, right? So one of the hydrogen atom of the benzene. So you replace this H by chlorine or bromine, or else you can replace this H by bromine. Whatever the H, you can replace that one and add halogen. So those are called haloarenes. In benzene ring, if you are replacing the hydrogen by halogen, that is called haloarenes. In alkanes, in aliphatic alkane, if you are replacing hydrogen by halogen, that is called haloalkane. I hope you understood. Now we are going to study the classification of haloalkanes. So classification of haloalkanes. So based on different category, depending upon different category, the haloalkanes can be differently classified. Carefully see here. Based on number of halogen atoms. Based on number of halogen atoms. Based on the number of halogen atoms, first category. Based on number of halogen atoms, haloalkanes can be classified in three ways. Look at here. First one is monohaloalkanes. Monohaloalkanes. Okay. Second one, dihaloalkanes. Dihaloalkanes. And third one is polyhaloalkane. Polyhaloalkanes. Look at the name. Based on number of halogen atoms. Look at here. Based on the number of halogen atoms. How many halogen atoms are present? So based on that, haloalkanes can be classified into three ways. Look at here. First one, mono. Mono means one halogen atom. So this is your alkane, nothing but methane. Replace one H and add one halogen. Is it? So this is your CH3. This is your, yes, two carbon atoms, single bond. It is ethane. So this is the ethane, right? So just you replace one hydrogen atom, CH2, and add one halogen atom. So this is haloalkanes, that too, monohaloalkanes. One of the hydrogen is replaced by chlorine or bromine or any halogen. So in second category, look at here, di. Di means two halogen group. So two halogen group means same thing you take. CH4 is your methane, right? Two hydrogen atom. This CH4 locates like this. Look at here. This is your CH4. So two halogen atoms are replaced by two hydrogen atoms are replaced by two halogen atoms. So that is called dihaloalkanes. So I hope you understood. Two hydrogen atoms are replaced by two halogen atoms, that is called a dihalo. Only one hydrogen atom is replaced by one halogen, that is called a monohalo. And last one is poly. More than two hydrogen atoms are replaced by halogen atom, that is called a poly. Look at here. This is your CH4, nothing but methane, right? Yes. So replace all three hydrogen atoms or four hydrogen atoms by any halogen atom. Okay, look at it. Three hydrogen atoms are replaced by halogen atom. Therefore, this one is called polyhaloalkanes. Or else you can take all the four hydrogen atoms can be replaced by halogen atom. That is also a polyhaloalkanes. So we have studied now classification of haloalkanes, that too based on number of halogen atoms. Based on the number of halogen atom, haloalkanes can be classified into three ways. First one is monohaloalkanes, nothing but that contains one halogen group. That means one hydrogen is replaced by one halogen. Second one, dihaloalkanes, in which two hydrogen atom is replaced by two halogen atoms. The third one, polyhaloalkanes, in which more than two, look at here, poly means more than two hydrogen atom is replaced by halogen atom. So halogen may be chlorine, bromine, fluorine and iodine. You can take any halogen atoms. Okay, so this is classification of haloalkanes based on number of hydrogen atom. So next category is classification of haloalkanes. Classification of haloalkanes based on hybridization of carbon atom. Based on hybridization of carbon atom to which halogen atom is attached. To which halogen atom is second classification. Based on, look at here, hybridization of carbon atom to which halogen atom is attached. So all you know guys, what is hybridization? So I have studied in first year only. Hybridization means two atomic orbitals of nearly equal energy combine to form nearly identical, same number of molecular orbitals which are having identical energy. So those are called hybrid orbital, and the phenomenon is called hybridization. You have already studied sp hybridization, sp2 hybridization, sp3 hybridization, right? So sp3 hybridization means it is having only single bond. It is having single bond. sp2 double bond. sp triple bond. Okay. So what we have to classify here, classification of haloalkane, second category, based on hybridization of carbon atom to which halogen atom is attached. So either it is attached to carbon-carbon single bond or carbon-carbon double bond or carbon-carbon triple bond. Based on that, we have classified the haloalkanes into several categories. In that, first one is alkyl halide. Alkyl halide. So alkyl halide means nothing but alkane. In alkane, hydrogen atom is replaced by halogen atom. Look at here. In alkyl halide, so you write any halogen, any alkane group, C2H6. This is ethane. Look at here, two hydrogen. So what is alkane general formula? CnH2n plus 2. So n is 2 right here. 2 2s are 4 plus 2 6. C2H6. 2 carbon eth. All are single bond A and E. So name of this one is ethane. You have already studied in first PUC only. This is ethane. So replace any hydrogen atom by any halogen atom. So this becomes alkyl halide. C2H5Cl. So chloroethane, what we can call. So this is alkyl halide. So again in alkyl halide, we have classified three categories. First one, primary alkyl halide. Okay. Second one, secondary alkyl halide. And third one, tertiary alkyl halide. Look at here, primary alkyl halide, nothing but It is a haloalkanes, nothing but alkyl halide or haloalkanes, in which the chlorine attached carbon is there. No, that carbon should attach to at least one substituent or no substituent. Look at here how the example is there. So this is your methane molecule. Yes, one halogen is a no substituent, all are H only. So if one H is replaced by CH3, that is also called primary alkyl halide. Look at it, primary carbon. This carbon is called primary carbon atom. Only one substituent. Look at here. Primary means carbon having one substituent. Remaining all side we are having H only. One substituent. Or maybe CH3, C2H5, whatever. Secondary means two substituent. Look at here. This is your whatever it is. This is your chloromethane. So replace one H, add one. Another replace another H, add another one. So two alkyl groups, two substituent are there. That is called secondary. Tertiary means three substituent. Look at here. Three substituent, one side chlorine. So this is primary, only one substituent. Secondary, two substituent. Tertiary, three substituents. So these are primary, secondary and tertiary carbons. So come here. So primary alkyl halides having only one substituent group. Look at here. This is carbon atom, primary carbon attached to one substituent. So therefore it is called primary alkyl halide. This is alkyl halide. Only one substituent is there. Therefore it is primary alkyl halide. So similarly, you can take a look at here. This is CH3. Another H is replaced by another CH3 or any C2H5, anything. So two hydrogen atoms are replaced by two alkyl atoms. So therefore this one is secondary. So if all the three hydrogen atoms are replaced by three alkyl atoms, then that is called tertiary alkyl halide. I hope you understood. So this one is nothing but classification of haloalkanes based on hybridization of carbon atom to which halogen atom is attached. In that, firstly we have classified regarding first one. In this category, we have first one, nothing but classification. Look, okay. Classification based on hybridization of carbon atom to which halogen atom is attached. In that, first one is alkyl halide. In alkyl halide, again primary, secondary, tertiary. In alkyl halide, carefully see here, this carbon is having single bond in all the different ways. Look at here. Around this, only single bonds are there. So therefore, this one is called sp3 hybridized carbon. Look at here also. All are single bond. Therefore, this is also sp3. Look at this carbon attached to halogen attached to this carbon. So this carbon having single bonds only. Therefore, this is sp3 hybridized. Therefore, this classification comes under. So carbon atom to hybridization of carbon atom. That is nothing but sp3 hybridized carbon atom. sp3 hybridized carbon atom. sp3 hybridized means all are single bond. Look at here. This carbon, the halogen atom is attached to this carbon. This carbon is having all single bond throughout. Here halogen atom is there. This is attached to this carbon. Here also all single bonds are there. This halogen atom is attached to this carbon atom. All are single bond. Therefore, we can call it as a sp3 hybridized carbon atom. Nothing but classification of haloalkane based on the hybridization of carbon atom to which halogen atom is attached. This halogen atom is attached to this carbon. So this carbon having sp3 hybridization. Therefore, this category comes under sp3 hybridized carbon atom to which halogen atom is attached. So first one. In that, first one is alkyl halide. Okay. So second one is allylic halide. So allylic halide is nothing but, look at here carefully. This is carbon-carbon double bond. Next carbon we have to add the halogen. So carbon-carbon double bond, this is sp2 hybridized. So this carbon-carbon single bond, look at here. Halogen atom is attached to carbon atom which is having single bonds only. Look at it. This single bond, these three H's are like this. Is it? Single bond, single bond, single bond, single bond. So this is sp3 hybridized only. But next to that carbon atom having double bond. So this group is called allylic group. Which group? Allylic. So second, based on the hybridization of the carbon atom to which halogen atom attached. First one is alkyl halides. Second one is allylic halide. So allylic halide means the halogen atom is attached to carbon atom next to carbon carbon double bond. Here halogen atom is attached to carbon atom next to carbon carbon double bond. Next to carbon carbon double bond. Look at here. Carbon carbon double bond is there. Next carbon atom is having Cl. But this carbon atom is sp3 only, because all are single bond sp3. But this is sp2. We don't need this one because halogen atom is attached to carbon. That is sp3. So this we want. This is second classification. So again in this, third one is benzylic halide. Third one is benzylic halide. Carefully see here. Benzylic halide. So benzylic is nothing but, look at here, benzene ring is there, no? Next to benzene ring. Look at it like this. That means this is H, this is H, this is Cl. So halogen atom is attached to carbon atom which is next to benzene ring. Is it? So next to benzene ring is there. That is called benzylic halide. So what we should write then? Halogen atom is attached to, yes, halogen atom is attached to carbon atom next to benzene ring, So this type of example, this type of haloalkanes are called benzylic halides. So this is also sp3 hybridized category. Look at here. Halogen atom is attached to this carbon. So this carbon is having all single bond. That means this is sp3 only. sp3 hybridized carbon only. So this one is regarding sp3 hybridized carbon. In second category of classification of haloalkane is based on hybridization of carbon atom to which halogen atom is attached. In that, first one is sp3 hybridized carbon atom. In sp3 hybridized carbon atom, first one is alkyl halide, second one is allylic halide, third one is benzylic halide. Now in same category, we are having sp2 hybridized carbon. sp2 hybridized carbon. Look at here now. This is third one. No? We can continue fourth also. Fourth and fifth are classification based on sp2 hybridized carbon. So here next one. Classification based on sp2 hybrid carbon. sp2 hybrid carbon. Look at here. In this again first one is vinylic halide. Vinylic halide. So vinylic halide is nothing but halogen atom is attached to. Look at here. Halogen atom is attached to directly carbon carbon double bond. So this one is called vinylic. Look at here. Double bond is there. This carbon having double bond. Halogen atom. Therefore this one is sp2. Look at here. sp2 hybridized carbon. This is vinylic halide. And here in second one, it is having aryl halide. Aryl halide or benzyl halide. Whatever I can call haloalkanes. Haloarenes. Look at here. Directly attached to benzene ring. So in previous case, we have studied benzylic halide. That benzylic halide is having halogen atom is attached to carbon atom next to benzene ring. In this way we are having in that case benzylic, but here directly to the benzene ring. Therefore this one is called aryl halide. This one is called vinyl halide. Vinyl halide means halogen atom is attached to carbon atom which carbon carbon double bond. Halogen atom is attached to carbon which is having double bond, nothing but sp2 hybridized carbon. Here also look here. So this carbon, halogen atom is attached to this carbon. Look at here, the single bond, double bond. Here also double bond is there. So this is also sp2 hybridized carbon atom. So this much regarding based on the hybridization of carbon atom to which halogen atom is attached. So this one is classification based on hybridization. So first one what we have studied, the classification of haloalkanes based on number of halogen atom. In that three cases. What are three cases? So just we will recall, then we will move on to the next one. Look at here. First, what we have studied, classification based on based on number of halogen atoms. Number of halogen atoms. Okay, in that first one we have studied monohaloalkane. Monohaloalkane. Next one dihaloalkanes. Third one polyhaloalkane. Polyhaloalkanes. In dihaloalkanes, so I have just forgotten to tell you guys. In two dihaloalkanes, again two categories are comes here. Look at here. Dihaloalkanes are nothing but the haloalkanes in which two halogen atoms are present. If both the two halogen atoms are attached to the same carbon atom, then that is called geminal dihalide. Geminal dihalide. Okay. If both the halogen are attached to adjacent carbon atom, then that is called vicinal dihalide. Look at here. Look at here. Both the halogen atoms are attached to this one. Same carbon atom, that is geminal. So both the halogen atoms are attached to adjacent. This carbon atom, this adjacent to this. So if adjacent carbon atoms, the halogen atoms are attached, then that is called vicinal dihalide. Vicinal dihalides. So I hope you understood dihaloalkanes. There are again two classification. Geminal, gem means same carbon atom halogen atoms are attached. Vicinal means adjacent carbon atom halogen atoms are attached. Then what about polyhaloalkanes? Polyhaloalkanes are nothing but more than two halogen atoms are present. So those are called polyhaloalkanes. Yes. So this is classification based on number of halogen atoms. So second category what we have, based on hybridization of carbon atom to which halogen atom is attached. To which halogen atom is attached. Again in this, again we are having two. First one is, you write this one. First one is sp3 hybridized carbon. Second one is sp2 hybridized carbon. Yes, in sp3 hybridized carbon again first one is alkyl halide. In alkyl halide again three: primary, yes, secondary and tertiary. Yes, in again second one sp3 hybridized carbon. Second one is allylic halide. Third one is benzylic halide. In sp2 hybridized carbon, two we have studied. First one is vinylic halide, and second one is nothing but aryl halide. So this much we have studied with each example. So primary means only one substrate, secondary means two substrate, tertiary means three substrate. Allylic halide means next to the carbon-carbon double bond. Benzylic halide means next to the benzene ring. sp2, so attached to the carbon-carbon double bond. Vinylic means carbon-carbon double bond. Aryl means directly benzene ring. So this is classification of haloalkanes. I hope you understood, guys. Trivial system in another than common name, what we can call common name. Another one is IUPAC system. So IUPAC means International Union of Pure and Applied Chemistry. So in trivial system, common system, we call haloalkanes as a alkyl halide. And in case of IUPAC system, we will call as a haloalkanes. So alkyl halide, how it comes? Look at here, guys. I will explain with an example. So this is your CH3, CH2 and Br. So alkyl. So which alkyl group is there? Carefully see here, 2 carbon atom. That means 2 carbon atoms, that is called ethane. So one of the H is replaced by Br. So therefore this one is called ethyl. Br means bromide. So what is the name then? Ethyl bromide. Look at here. Alkyl halide. Whatever the parent alkane is there, that you have to take a alkyl. So here it is an alkane. This one is commonly called as ethyl. Halide means here bromide is there. We have written bromide. Similarly, you can take another example. CH3, CH2, CH2, Cl you take. Now here halogen is chloride. And what are the, how many numbers of carbon atoms are there? 1, 2, 3. 3 carbon atoms means prop. So what is there then? Propane is there. So we have to write propyl. Propyl chloride, because chlorine is there. So in this way we can name common name for the haloalkanes. Nothing but alkyl halide. Remember this word. Alkyl halide. In IUPAC, so taking the same example, we will explain here. Look at here, I will explain. CH3, CH2, Br is there. So haloalkane. So what is halo group here? Bromo. Yes, bromo. So how many carbon atoms are there? 2. 2 means all are single bond. Ethane. Bromo, ethane. Take that example. CH3, CH2, CH2 and Cl. So here halogen group is chloro. Look at here. Halo. So here it is chloro. Right? Chloro. With prop. So propane. Chloro, propane. So in this way we can name the haloalkanes by trivial system alkyl halide and by IUPAC system haloalkanes. So now we will be going to study some examples. So common name also and IUPAC name also for these examples. Okay, these are NCERT examples. So look at here, how many carbon atoms are there? 1, 2, 3, 4, 5. 5 carbon atoms, and bromine is, you have to name like this, right? First carbon, second, third, fourth and fifth. So bromine is a halogen group, is attached to first carbon atom. And how many carbon atoms are there? 5. 5 means pent. So first carbon atom bromine. So what we can call for common name? This is pentyl bromide, right? So in common name what we have? Alkyl halide, right? Alkyl halide. And in IUPAC name haloalkanes. Haloalkanes. So look at here, in common name alkyl halide. So what is alkyl group here? Alkane, pentane. So pentyl bromide. So common name is pentyl bromide. But in IUPAC name, look at here, haloalkanes. What is halo? Bromo and pentane. So bromine is attached to first carbon atom. So therefore this one is 1 bromo. 1 bromo pentane. YANE, all are single bond here. Okay, come to the second example. Look at here. How many carbon atoms are there? You can name like this way or this way. Number. Second carbon atom, chlorine is attached. So there 2 chloropropane. But look at here, in common system, wherever the branch comes, no, you have to add the word iso. So this is isochloropropane. For a common name, it is isochloropropane. Isochloropropane. Or else isopropyl chloride. You can name like this also. Isopropyl chloride. Isopropyl chloride. So branch comes, you write iso. Iso with its prop is there, propyl chloride. But in that way, same. Haloalkane is there, no? Second position, chlorine attached. So this is propane. 2 chloropropane. What is the name? 2 chloropropane. Okay. Then come to this one. Look at here. Methith prop. So you can take in this way naming 1, 2, 3. So first carbon atom chlorine is attached, second carbon atom methyl is attached. So you can go for IUPAC 1 chloro 2 methyl propane. But in common name, this is called isobutyl chloride. Look at here, 1, 2, 3, 4 carbon atoms are there. Here 3 carbon atoms are there, chlorine is attached. Therefore isopropyl. So here 4 carbon atoms are there, chlorine is attached. Therefore it is isobutyl chloride. Isobutyl chloride. Branching is there, you have to add iso group. But here, look at here, that IUPAC, first carbon chlorine, second carbon methyl. So 1 chloro, 2 methyl propane. Right here. 1 chloro, 2 methyl propane. So you have to write a hyphen in between letter and a number and write a comma in between letters. So you have already studied in the first PUC only, the naming of IUPAC naming. So fourth example, look at here, with prop. You can name like this or like this. Now, all time you are writing the same numbering. So I will write like this, look at here, 1, 2, 3. Second carbon chlorine is there. Second carbon methyl group is there. So in IUPAC what should we write? 2 chloro, 2 methyl propane. 2 chloro, 2 methyl propane. Okay. In common name, this is called, look at it, 1, 2, 3, 4. So this carbon is tertiary carbon atom. This carbon atoms to 3 alkyl group. Therefore, this one is called tert butyl chloride in common name. It is called tert butyl chloride. Tert because it is tertiary carbon. Look at here. This carbon attached to 3 different carbon atoms. So 3 substituents. Therefore, this is called tert. Okay, capital right, you write capital T. Tert butyl chloride. Last one, look at here. So you can name this way or this way. You have to name this way because chlorine that is branched should get lesser number. 1, 2, 3, 4 and 5. So second carbon atom chlorine. So in IUPAC name what should we write? 2 chloro. 5 carbon means pentane. Right here. 2 chloro pentane. But in the common name we should write this one is a SEC. Second position chlorine means it is SEC pentyl chloride. SEC pentyl chloride. So these are the some names for IUPAC and common names for some example. So this is regarding the nomenclature of haloalkanes. Now in the next coming classes we are going to discuss the preparation and some chemical properties, chemical reactions and some physical properties of haloalkanes. So this is regarding this class, guys. Thanks for watching. I hope you understood the concept. If you have any queries regarding that, please comment below.